ladies and gentlemen. My name is Khalid Mahmoud. I work at Saudi Aramco Jeddah Refinery Department Engineering Division. I would like to thank you all for attending this presentation and wish it will be beneficial. The objective of my presentation is to share with you our experience in utilizing internally epoxy-coated valves in SeaWater applications. I will start giving a brief description about Jeddah Refinery Department, followed by a cooling water system setup. I will then review Jeddah Refinery experience and findings utilizing internally epoxy-coated metal and resilient seated type gate valves in refinery cooling water system. After that, I will share with you Saudi Aramco SeaWater injection plant experience using epoxy-coated valves in SeaWater intake service. Finally, I will conclude my presentation summarizing the key issues related to using internally epoxy-coated valves in SeaWater applications. Jeddah Refinery is part of Saudi Aramco Refining and Distribution Organization, commissioned in 1967. It is located at west coast of Saudi Arabia on the Red Sea. It is a conversion refinery with a maximum sustainable capacity of 85,000 barrels per day of Arabian light throughput and 80,000 barrels per day when Arabian heavy crude is processed. Jeddah Refinery produces LPG, gasoline, naphtha, diesel, jet fuel, fuel oil, and asphalt. The refinery products are distributed mainly to the local market. I will now give you a brief description of Jeddah Refinery cooling water system configuration utilized in refinery operations. The cooling water system using SeaWater from the Red Sea consists of 6 cooling water pumps at marine area, connected to 2 36-inch headers and branched to 3 30-inch size pipelines running about 3 kilometers from the marine area to the refinery filter stations. The cooling water stream split downstream the filter station into 3 main subheaders, supplying the process and utility areas with 30,000 gallons per minute capacity demand. I will share with you now Jeddah Refinery experience and findings utilizing internally epoxy-coated metal-seated gate valves in refinery cooling water system. Jeddah Refinery installed in 2003 26 motor-operated gate valves of 18, 24, and 30-inch sizes. The cost for the MOV was about $1.2 million. The valve body is carbon steel internally coated with a National Oil Varco Tuboscope system and approved Aramco coating brand for valves in SeaWater applications. Valve trim material are Monel 400. Several of those valves found severely passing after placed less than a year in service due to internal corrosion resulted from the coating failure, to be shown in the following slides. Sample of the 24-inch size MOV installed in 2003 is shown. API 600 gate valve is the most widely used valve type in Saudi Aramco refinery applications. The premature coating failure for the metal-seated gate valves occurred at the valve seat area and disc guides. Severe corrosion and metal loss noted on the seat area and guides, where the coating found damage, leaving major substrate area unprotected and exposed to seawater. Seawater ingress at the coating cracked locations developed galvanic corrosion activities that had resulted in significant damage to the valve's internals and made them profusely leaking, impacting Jeddah Refinery cooling water system operation. The valve failure correlated mainly to wrong coating applications, as the valve manufacturer machined the seat ring area after coating application to the valve's internal body to remove excess coating. This had resulted in chipping and cracking of the coating, which eventually allowed corrosion to occur at the valve sealing area. In addition, the valve has two guides to align and smooth the wedge operation during opening and closing of the valve. The manufacturer should have properly overlaid the parts susceptible to wear, such as the body bonnet, male wedge guide, female wedge guide, and the T-head with corrosion-resistant alloy prior coating application to avoid the damage of the wedge as a result of the wedge mechanical movement. I will talk now about using other gate valve style in Jeddah refinery cooling water system. Jeddah refinery installed in 2008 6 resilient seated MOV gate valves of 24-inch sizes at the desalination filter station. The valves are in compliance with American Water Works Association C509 standard. Valves are made of ductile iron button, internally fusion bonded epoxy coated with Scotch coat approved ARAMCO coating system for SeaWater. Valve disc is made of ductile iron APDM rubber encapsulated. The valve start devolving leak after placed 2 to 3 years in service. The valves were pulled during the refinery T&I activities in 2013 for maintenance repair. The shown picture reveals coating damage at the valve seat area. Also, it was noticed that severe damage noted on the EPDM rubber encapsulated discs for those valves. Coating was repaired by Belzona compound 1321 ceramic base coating type. Furthermore, damaged discs were replaced with new ones. I will share with you now valve coating failure case from Saudi Aramco, world's largest seawater injection plant located eastern of Saudi Arabia on the Arabian Gulf. Water injection for oil fields is critical. Without water injection, oil production levels cannot be maintained and could be significantly impacted and dropped. Injected seawater replaces the oil that is extracted from the reservoir. This offsets the pressure decrease in the field that is caused by oil production. Several valves have been replaced due to coating failure, impacting seawater injection plant operational reliability and maintainability. The coating failure in the shown metal-seated ball valve at the flange face and edge and seat area are attributed to wrong coating application procedure, including the coating termination point at the valve seal and flange areas, insufficient coating thickness, and poor quality and inspection techniques implemented. In conclusion, a significant number of internally epoxy-coated valves installed at Saudi Aramco operating facility in seawater leak profusely. Internal geometric configuration of valve can cause isolated areas with incorrect applied coating procedure. If this happens, valve failure is imminent. Controlled coating procedure, including coating material and thickness, cleaning and surface preparation, coating application, inspection and quality, coordination between the valve manufacturer and applicator is an essential elements for the valves in seawater application to survive. I would like also to draw attention that the reference industry standard for valves internal coating, followed by most of valves manufacturers, is American Water Works Association C550, protective interior coatings for valves and hydrants. AWWA C550 exclude clearly SeaWater protective coating from its scope. More stringent coating requirements are mandated for valves in SeaWater services that must be established and agreed upon between end user, valve manufacturer, and applicator based on service condition, design configuration, and product specifications. Based on our experience, we believe for critical seawater application, corrosion-resistant metallic valve body and internals is the correct choice to select for gate valve type. Internally rubber-lined butterfly valves with corrosion-resistant metallic disc is the optimum choice to select for seawater intake applications. By this, I conclude my presentation. Thank you for listening, and I'm willing to answer any of your questions.
Thank you.
Thank you very much. If you have any questions?
Yes, please.
No problem.
This is thank you for your presentation. I have two questions. First one is, did we share this information with the supplier?
Yes, as a matter of fact, the supplier, the valve supplier, who wrongly applied the coating and machined the seat, he was brought by Aramco and he refunded Aramco for the valves he supplied in this application, because he agreed that it shouldn't be done, that he applied the coating and then he machined the seat area. So there was a claim raised by Aramco on the valve manufacturer, and he refunded Aramco with about 70 to 75% of the cost of those valves.
Okay, and second question, is the supplier or was the supplier aware that these valves will be installed in seawater severe application?
Yes, sir.
So from the beginning they knew about it?
Yes, it was written on the purchase order that those valves will be installed in seawater intake service. So he was aware of that. Because of that, he accepted the claim and he refunded Aramco with about 70 to 75% of the initial cost.
Thank you.
Good morning. My name is Eugenius from Petrobras. Very interesting your presentation. I would like to ask you something. I saw that you have.
Liebe Besucher, wir möchten Sie darauf hinweisen, dass die Eintrittskarten der ValveWorld Expo auch für die Pump Summit gültig sind. Dear visitors, we would like to point out that tickets to ValveWorld Expo are also valid for admission to Pump Summit.
I saw that you have chosen gate valves and ball valves for saltwater service. In terms of gate valves, they are wedge gate valves, so they consist of mechanical energization between obturator or gate and the seats. This might create problems in terms of resistance of the coating. And also you have used ball valves that appears to be metal seated, so should be trunnion mounted ball valves. So you have them floating and you have a controlled stress on the resilient parts. Would you assume the epoxy coated ball valves would be more adequate for saltwater service if properly designed and sized than gate valves? What are your comments about this?
You see, in water intake system, for example, I'm talking about jet refinery. The main cooling water pump, extracting the seawater from the Red Sea, they have at the discharge of the 6 cooling water pumps, ball valve for isolation. The ball valves are working in satisfactory manner. They are internally coated, but it was coated properly, so we have no problem with that. But the cases shown for Korea SeaWater department, there was failure in coating application. So ball valve, if it properly coated and terminated the points, and there is no crack or will be no damage, it will work fine. Our experience revealed that there are internally coated ball valve work well in SeaWater service.
Okay, and considering the gate valve, the way it is designed, and the stresses the materials suffer, would you consider them still adequate to be epoxy coated, or you should suggest to use corrosion resistant alloys for such application?
It should be for the moving parts like the wedges and the key head. It should be corrosion resistant. They cannot be only coated. The moving parts for the gate valve, the API 600 gate valve, should be corrosion resistant alloy to sustain the SeaWater services. We have manufacturer here, for example, gentlemen from Orient, they provide an excellent valves for installed API 600 in SeaWater successfully because they have, applied the corrosion resistant alloy on those moving parts. So it depends on the manufacturer if he knows what to do or he lacks the experience of utilizing this.
So the bottom line would be that you believe that gate valve would be feasible to be epoxy coated if you do not rely on just carbon steel, but you rely on the guide plates and other moving parts or contact stresses to be appropriately corrosion resistant alloys.
Yes, it's okay. Let me tell you something. The resilient seated gate valve for the intake service is a weak. Generally, for the intake services where you need frequent opening and closing for the valve, you need to have a bulk and strong valve. The API 600 possesses the strength compared to the resilient seated gate valve. You see in the resilient seated gate valve, the EPDM disc already cracked from the services because it's aggressive service. SeaWater intake is an aggressive service. So the valve should possess the strength to sustain the service.
I agree with you. We have had similar problems. Thank you very much.
Okay. Any questions? Please.
What valve did you put back in? Did you put butterfly valve back in?
Excuse me?
Did you put butterfly valve back in?
Yes. You see, in our cooling water system, we have butterfly valve, metallic seated butterfly valve,
offsets.
internally lined with hard rubber. Those are the best you can use for SeaWater intake application. It lives for 10, 15 years. You see, other things, if you want to use, for example, based on our experience, we have used cast iron gate valve. It is ASTM A126 grade B with B61, B62 trim material. They work well in the SeaWater. But you see, in my opinion, internally coated valve is a risky to use for SeaWater intake services. Experience proven. It had failed in Jeddah refinery, Ras Al Noura refinery, Korea SeaWater injection plants. Several of our plants suffered from the internally coated valve.
Have you guys changed your specs?
You see, I don't see here the CSD colleagues are available here. They can answer if they will change the spec or not. But you see, in our side, we don't now buy any internally coated valve and install it in our cooling water system.
Thank you, Khalid. My name is Badr Jalal. I'm the standard chairman of valves in Saudi Aramco. I just would like to elaborate. Now our specification to go for large sizes as cost-effective option, we go for internally coating. I think we are the only guys. I think there is another company in Canada also specify FBE coating. But anyway, for Europe, we are the main customer for FBE coating. I think our weak point in our standard is the termination points were not well defined. The seat pocket area, the seat connection, the flange connection, these critical areas should be covered by high corrosion resistant material. FBE coating, from our experience, gathered data that at this location, critical location, we have the corrosion to start. I think from our experience, if you have the critical areas, including the flange, face, the seat pocket area, and the seat for example, for the gate valve, the back seat should be weld overlaid by high corrosion resistant material. FBE coating is doing fine. We don't have a complaint, and it is a cost-effective option. For sure, a contractor can supply high corrosion material, weld overlay, and Stedel, and this acceptable in our standard. We are developing the appendix to detail all parts for different type of valves based on our failure, and it will be included in our specification. Thank you.
See, I would like also to add things. In our specification, for example, 09, there is a document specifying the requirements for internally FBE coating. But this document is good up to 3000 psi pressure for high services application. Many valve vendors cannot co-op with this 09 SAMS document because they need especially differential scanning calorimeter equipment to achieve the degree of curing mandated in this document. So most of the valves manufacturers, they want to refer to AWWA C550, which is inadequate for SeaWater intake services or application, definitely.
Okay, thank you for this clarification. Now we will go through the next presentation about composite epoxy resin material.